In previous video, we have learned about the macroprocessor functions like macro definition and expansion, and also we have learned about the algorithms used for performing these macroprocessor functions. So we have learned the single pass algorithm of the macroprocessor, in which it is said that every macro must be defined before it is being called. One-pass processor can alternate between macro definition and macro expansion. Nested macro definitions may be allowed, but nested calls are not allowed in case of single-pass macroprocessor operations. In case of two-pass algorithms of macroprocessor, it performs some different steps. Pass 1 and pass 2 it will be having. During the pass 1, it recognizes the macro definitions, and in pass 2 it will be recognizing the macro calls. Such a thing is not being done in the single pass. Only one pass is there, and macros need to be defined before it is being called. In case of two-pass algorithm, nested macro definitions are not allowed, and in case of one-pass algorithm, single pass macroprocessor algorithm, nested macro definitions are allowed, but nested calls are not allowed. So these are some of the comparisons related to the macroprocessor. Next, we will be learning about machine-independent macroprocessor features, which includes the concatenation of macro parameters, generation of unique labels, conditional macro expansion, and keyword macro parameters. So, starting with concatenation of macro parameters, it consists of we will be dealing with some operators like pre-concatenation operator, post-concatenation operator. So here ampersand acts as the pre-concatenation operator, in which string x is concatenated with the label id1, or the string id x is concatenated with the parameter, macro parameter id1. And in this case, post-concatenation, the purpose of post-concatenation is to delimit the macro parameter. That is, macro parameter variable, it can be something that is id1. Here, id1 can be considered as a macro parameter variable. Ampersand id also will be considered as the macro parameter. So here, an ambiguity will occur whether it is ampersand id or whether it is ampersand id1. So in order to delimit between the variables, that is the whole thing to be taken as a macro parameter, we make use of these two operators, ampersand and arrow, in order to delimit the usage of the macro parameter variable. So the purpose of this macro parameter variable is like, if a program need to be written such that it will be dealing with some series of variables like xa1, xa2, xa3, xas, and some other series of variables x beta 1, x beta 2, x beta 3, and x beta s. So these variables will be performing some same set of operations. So in such a case, we make use of the macro parameter, and concatenation will be done in order to include the variable a and beta in place of ampersand id. Okay, so here a macro parameter ampersand id is being introduced, and LDA x ampersand id arrow 1, like this it will be used, which means that during the expansion phase, this ampersand id will be replaced with the variable that is given in the macro call. So resulting in performing the same set of operations. And this arrow operator, it will not be specified in the expanded statements. So this is a case of concatenation of macro parameters, in which using the pre-concatenation operator ampersand, it attaches or it concatenates the string x with this macro parameter variable id1. And using the post concatenation, what it does, it will be able to delimit the macro parameter variable, and also it helps in I'm concatenating the variable with the right hand side string 1, 2, 3. Here it is 1. Okay. Then next is generation of unique labels. Here we can see that jump if equals star minus 3. Usage of this is inconvenient, error prone and difficult to read. So in order to avoid this usage, we can directly make use of the labels, and the labels need to be generated in such a way that during each call a unique label will be generated. For example, if the program consists of a label $loop and label is there, test device, some input device is given, X and indir. During the first call, it generates a unique label like $AA loop. Name it gets different. Some 2 letters is being added here, AA. And the in device will be given as in the macro call statement, it might have given us F1. So this indiv is replaced with this F1. And during the second call also, what happens? It generates the label like starting with AB loop. Third call, it becomes $AC loop. Like that it goes on. Okay. So here we can say the example. Macro is being defined here. How we understood that it is a macro definition statement? Because macro is placed in the opcode field. Opcode field. Okay, it is having a main directive also. So this is one macro definition. And if a macro call invocation is given like this, rdbuf f1 comma buffer comma length, means the macro invocation statement will be changed like this. In place of indiv, it becomes f1. So here in the source program, it is having a label $loop and $exit. So during the first invocation, so this is the first invocation. So during the first invocation, it generates the labels $AA loop and $AA exit. Okay, and during the second invocation, it will be generating AB loop, AP exit. And instead of using jump if equals here, in previous videos we have seen one example like star minus 3. So instead of using that, directly you can make use of the labels $AA loop. Next is related to conditional macro expansion, in which we make use of some macro time conditional statements and macro time variables. So macro time conditional statements means it using the if, else, end if, and macro time variables will be like it starts with the character ampersand and is and will not be mentioned as a macro parameter. It will not be treated as a macro parameter, but the macro time variable, it will be starting with the character ampersand. And also these macro time variables, they are initialized to 0, and if we need to change the value of macro time variable, means you need to use the directive set. So ampersand EORCK set 1 means will be initialized to the value 1. If this statement is not used, means automatically by default it will be initialized to the value 0. So here is one example in which ampersand EORCK is being used. So here ampersand EORCK, it is not mentioned in the list of parameters. Okay, so all the parameters, they are given the our character ampersand, and there might be some symbols that is used in the program starting with ampersand. such variables will be called as the macro time variables. And here EORCK is set as 1, which means it is initialized to 1. So when this program is being invoked using some call statement like rdbuff f3 buff recl042048 means what all operations will be done. Here these macro time variables and macro time conditional statements will not be included in the source, that is the expanded code. So it will be starting with, expanded statement will be starting with this clearx, clear A. So clear X, clear A. Then if is not being used, this if also it is a conditional macro time conditional statement. It is not used in the expanded code. LDCH RMO and if LDCH RMO and if will not be used. LDCH and RMO will be used. That is, if ampersand EORCK equals to 1, these statements will be included. If this condition is false, then these statements will not be included. Again, this if, instead of this if, it checks for the statement. If that condition is true, the statement will be included in the expanded code. Okay. So in this case, if max length equal to null. So here max length is given as 2048. Okay. MXLTH. MXLTH. It is given in the form of argument like 2048. So it is not equal to length. So what it does, it will not be executing this LDT statement. It will not execute. It will be executing. That is, it will be writing this statement. This LDT statement will be written here. Okay. LDT hash 2048. LDT hash max length value need to be displayed. Okay, so this is the purpose of the macro time variables and macro time conditional statements. While expanding the code, these variables and statements will not be written on the expanded code. It will be used for conditional checking and execution. If it is true, the following statements will be included, not the conditional statements or macro time variables will be included in the expanded code. So similar is the case for the next example also, that is rdbuff 0e buffer length. Here the EOR value it is not given, and 80 is the max length. So if EOR not equal to null, then only it will be setting the ampersand EORCK value as 1. And if EOR value is equal to null, then what happens? It won't execute this ampersand EORCK set to 1. Instead, wherever ampersand EORCK is being invoked, it will be equal to 0. Okay, it will be equal to 0 if EOR is equal to null, because it won't be executing this statement. Okay, so here clear X, clear A, and then what happens? It checks whether EORCK equal to 1. It is not equal to 1, so it checks for the next statement, max length equal to null. It is not equal to null, so it just displays the maximum length, that is LDT 80. Okay, LDT 80. This is how the macro time variable and macro time conditional statements. Macro time looping statement, next we are going to see, like making use of the while NW statement. Here we will be making use of some function like percentage n items, in which it monitors the number of members in an argument list that is given during the macro call. So this is one example in which macro definition, it will be having some parameters, and here ampersand EORCT, they are the macro time variable, which it is not mentioned in the macro parameter. It makes use of a function n items ampersand EOR. So EOR will be having some set of items, and seeing that set of items, it will be taking the count, and that count will be set as EORCT. Then, so as we have said earlier, this EORCT will not be included in the expanded code. Clear X, clear A, LDT, these things will be included. And the variables ampersand loop, ampersand CTR. Okay, dollar loop. Dollar loop is the label name, and ampersand CTR, again CTR, it is not mentioned here in the macro parameters. So ampersand CTR also will be considered as a macro time variable, which is set as 1. Okay, again ampersand CTR, some operation is being performed, and ampersand CTR is set as ampersand CTR plus 1. Here we are making use of a while statement, and if there is a while, then there should be an end while also, similar to the curly brace opening and close. Here while, if it is used, then NW we are using. If we are using means we make use of endif. Similarly, while NW. So when this macro invocation is, macro call is given like rdbuff f2 buffer length 000304, which means that EOR is having these three parameters 00, 03 and 04. So when this function ampersand percentage n items of ampersand EOR, if it is taken, means it will be returning the value as 3, because EOR is having 0003 and 04, count is 3. So ampersand EORCT will be set as 3. Clear the values, clear X, clear A. Then what it does, LDT 4096, TD is equal to X in device. In device here it is given as F2. So F2 will be written. Okay, F2. Then jump if equals dollar loop. So here dollar loop. So when a first macro invocation is done, it becomes dollar $a loop. Okay, so here dollar $a loop. Jump if equals dollar $a loop. Then RD is equal to X input device F1 will be given. Then set ampersand CTR set 1, which means here we are making use of the macro time variable. This macro time variable will not be reflected in the expanded program. See, macro time variable is not being used, and then it just initializes the value to CTR, and then again a conditional loop statement is used, that is while, that it will not be reflected in this expanded program. It just checks for the condition ampersand CTR whether it is less than or equal to ampersand EORCT. CTR is currently set as 1, whether it is less than or equal to EORCT, which is set as 3 based on the macro call. Okay, based on the macro call it is set as 3. So from this it says that true. So if it is true, compare is equal to X0000 ampersand EOR. Ampersand EOR, here what is the value? First it takes the value 0. That is 03. Ampersand EOR, ampersand CTR, that is 1. Okay, So here we will be giving the expanded program will be like COMP X. These 4 zeros, it is given in the program itself, and this 0 will be taken from here, EUR. First record of the EUR, or the first argument of the EUR. Then jump if equals $AX, that is given in the program itself. Okay, jump if equals $exit. So since it is a first invocation, it becomes $AA exit. Okay, $AA exit. Then set CTR plus 1. So this is a macro time variable. So just operation will be done, but it will not be reflected in the expanded program. And then end W. So this operation will be repeated. These while statement operations will be, these set of statements will be repeated until the CTR value is not less than or equal to EURCT value. Okay, so now after first invocation, that is first loop, first iteration, ampersand CTR value will be equal to 2, and ampersand EUR, it checks with ampersand EURCT. So ampersand EURCT is 3. So 2 less than or equal to 3, yes. So what it does, compare COMP is equal to X, these 4 zeros, EUR is that record that is given in the argument, ampersand CTR is currently 2. So from the invocation statement, the second argument will be taken of the EUR. Okay, so that is, this will be given in the expanded program. Jump if equals again $AX. Similar is the case for the third entry also. Okay, 04 will be taken, A exit. So once it exits from the loop, what it does, it writes the remaining statements in the program, STCH, DAXR, JLT, till the mend directive, all the statements will be written. So this is a process that is done by the while loop. Next is, so this much is related to the conditional macro expansion, which consists of conditional if statement, conditional while statement, loop statement, then macro time variables. We make use of macro functions also. Next is related to the parameter substitution, in which we have learned that we make use of some positional arguments and keyword arguments. So how the values are being substituted, we are going to see. So here again it is a macro definition program, and when an invocation is given like rdbuff, buff address is equal to buffer, reclth is equal to length. What does that mean? In the formal argument, you will be having some buff ADR and reclth. In place of buff ADR and reclth, you need to put the values, actual values, buffer and length. See, buff ADR and reclth. In place of this, we need to put the actual value. For the rest of the arguments, already the values are given. So those values will be taken. And for these two variables, we will be giving the actual value that is given through the macro call statement. So this is a keyword parameter substitution based on keywords. So here another one example, like RDBuff, REC LTH length, buff ADR is equal to buffer, EOR is equal to nothing is given, in device is equal to F3. So in the definition part, already we have seen that REC LTH and buff address is left as unfilled, while other parameters were given some value initially itself. So here EOR is equal to null, it is given, which means that EOR is equal to null is given, which means that it is overwriting the previous value. So earlier EOR will be equal to 0.4, so that will be overwritten by the null value. And here in device is equal to F3, that also will be overwritten. See, F3 will be overwritten. Okay, here F1 is used because in the invocation statement F1 is not given as a that indiv value is not given. So by default, what is the value that is given, it will be taken. But in this example, indiv value is given as F3. So the value that is given in the current invocation, it will be taken. So this much is related to the macroprocessor machine independent features.